Hi, I'm Jennifer Isabella.
And I'm Laura Ketzel.
Your co-host for Forrester's podcast, What It Means, where we explore the latest market dynamics impacting executives and their customers. Today, we're joined by Vice President and Research Director Pascal Matzka to discuss the current state of autonomous vehicles. Welcome, Pascal.
Thanks for having me.
So maybe this is an assumption, but I think that most people think they know what autonomous vehicles are. But in this research, you really do, you take an interesting approach, right, and define some different levels of autonomous vehicles. So maybe you can start there and kind of take us through what those levels are.
Well, autonomous vehicles in and of themselves are nothing new. I mean, we've been looking at autonomous tractors and forklifts and other, physical automation practices around vehicles in industries for many years. What people tend to associate in autonomous vehicles mostly with, however, are autonomous passenger cars. And given the recent events and news that we saw around the city of San Francisco, where autonomous robotaxis got banned from the public roads, there's quite a bit of interest now into where are we really in the context of autonomous vehicles adoption. Just to give a little bit of an explanation, when we talk about autonomous vehicles, what we really talk about are vehicles that are able to sense the immediate environment, understand their exact location, and then can make decisions based on algorithms and data and input on how to behave given the context of their position and their environment. And so when we talk about this in the context of industries like manufacturing, logistics, and supply chain, we talk about autonomous vehicles operating in very confined physical spaces, a warehouse, a factory, or maybe take an autonomous train or tram, where you have, again, physical boundaries that prevent other people from sort of running across tracks and getting in the way of autonomous vehicles. With autonomous passenger cars, things are much more difficult because there you have uncontrolled environments, and therefore you need to have a lot more software, a lot of more data points, and a lot more sensors ultimately to help you decide on how the autonomous vehicle should behave. So when we talk about this in the context of the different levels of automation, we typically refer to a categorization that was developed by the Society of the Automotive Engineers back in 2014. And this has been sort of generally accepted as the terminology around which we then build autonomous vehicle adoption curves. Although similar kind of autonomous vehicle standardizations also exist separately for trains and other vehicles themselves. But think about, a level of automation that basically puts you as a driver still very much in control of driving a car. So the level of autonomous vehicles would range to the point where you would use a parking sensor to determine the distance between you and the next car, or maybe even using some kind of autonomous driving to assist you get into a parking slot. So that's what we define as partial automation along the lines of a level 2 automation of this particular kind of standardization, categorization. Everything that moves beyond that, where you basically, as a driver, no longer execute control over the car, but basically just monitor the car. That's what we define as level 3, 4 to 5, full automation, where then robotaxis, like in the case of San Francisco, make their own decisions about how fast they go, where to go, and so on and so forth. And that's where we typically have issues with passenger cars operating in public environments, where, again, you have to just collect so much more information in order to be safe. And also you have to predict, the behavior of people and other elements around you in order to, provide safe autonomous transportation. So this is why, in our research, we found quite clearly that where autonomous vehicles are currently the most effective is in these confined industrial environments, where it's, again, about warehouses or factories or trains and trams that, again, can operate within their confined physical spaces. And where it's much more difficult to execute fully autonomous driving is in those public road spaces, as I described.
So let's just give people a sense of the variety of the kinds of autonomous vehicles that exist in some of those combined industrial spaces. Because obviously, a lot of us who don't work in those environments don't see those things every day. So, Pascal, can you give some examples of the kinds of robots and other sort of automated and autonomous vehicles that you see in those spaces?
Well, imagine every warehouse when you order your goods online. You probably have autonomous forklifts in warehouses that do the picking and order management within the warehouse. You may have autonomous drones that complete product inventory around the warehouse or around larger physical spaces. You even have, to a certain extent, autonomous vehicles conducting over the road long distance journeys or conducting last mile routes delivery through an autonomous drone, for instance. So it's in that context where we currently see a lot of adoption because of also how supply chains and warehousing and transportation options in commercial scenarios have to become more resilient and more efficient. Other scenarios pertain to physical spaces that are confined because they are trams or train tracks. And so we see, autonomous trains or autonomous trams operating in, for instance, fairgrounds fairly autonomously, again, because they are more strictly controlled. Autonomous ships would be another example. We have over the last couple of years seen autonomous ferry transports of goods and other freight transporter services becoming fairly autonomous, again, because it's easier to control over the sea autonomous transportation than it is over the road. So again, it's always sort of dependent on a controlled physical environment that allows you then to make sure that the autonomous transportation happens in a safe and reliable context.
Autonomous vehicles have been meant to be coming to various spaces, constrained and unconstrained, for quite a while. And I think it's fair to say that there were loads of more optimistic predictions back in 2017 when we first did some research about this than we've actually seen borne out. So tell me a little bit about what specific things are driving the fact that we've got some very near-term applicability for certain of these kinds of autonomous vehicles. What's changed between, say, 2017 and now that has made this more possible?
Well, again, let's start with the commercial side of things, because again, this is where we've seen, as I said, a lot of traction in recent years. And this has to do with how supply chains have to become more resilient. Again, the pandemic has been a key driver for this. Not just only because people went online shopping and relied on timely delivery of certain goods during the pandemic, but also because we've used some of these autonomous vehicles, for instance, to drive safety regulation adherence in certain physical spaces. We've seen this in China and even in France, where autonomous drones were observing physical environments to monitor if people were actually adhering to distancing rules during the pandemic. So the pandemic has clearly played a major role, but overall, I would say, as it relates to supply chain and logistics, the overarching trend to make supply chains more resilient, to drive, timely delivery of goods and services, both for end consumers, but also for business to business customers, really has been a key driver in this context. The other driver, I would say, has to do with, in particular, larger cities trying to reduce traffic congestion and also ensure that air pollution is kept under control. We've seen the City of London, for instance, managing traffic using traffic signaling systems together with autonomous transportation technology to provide better services around public transport, and also to coordinate between private transportation options and public transportation options, giving preference to eco-friendly modes of transportation at traffic lights, for instance. So these are some examples that we've seen over the last couple of years really coming to the forefront. There's also an element of consumers obviously now deciding based on eco-friendly modes of transport around their transportation options, where they would opt for not just convenient, but eco-friendly modes of transport. And again, autonomous vehicle technology can play a role in this. So jumping on an autonomous tram or other ways of transportation would allow you to sort of meet your personal eco-friendly ambitions, if you will. And lastly, of course, we see car manufacturers also trying to differentiate themselves, more and more using autonomous vehicles technology as a way to provide superior customer experience in a car and around the mobility and end-to-end mobility ecosystem. So again, what we've seen here is the integration of the last mile, using robotaxis, for instance, into your mobility journey as a way to provide a better end-user experience. And car manufacturers in particular, of course, would like to be seen as forerunners in some of these technologies and are trying to integrate more of this autonomous vehicle technology into their own cars, but also trying to integrate other mobility ecosystem service providers into the end-to-end mobility stream. So that's where I think some of the core trends arise in terms of autonomous vehicles adoption.
What is your take on the timing of when some of these particular use cases or personal transportation has been all of the rage talking about autonomous vehicles, but how far out is that to be a real common thing?
Well, let's define 5 separate use cases here and then understand how the timeline works out. So the first use case, I alluded to this earlier, this is about moving goods and materials within these controlled environments, the campuses, the factories, the warehouses. This is where we already see significant adoption. So this is ongoing. This is where we now see things sort of accelerating. Next level up is the scenario where we move goods and materials in uncontrolled environments. So again, this is where we see, for instance, autonomous trucks driving on the German Autobahn, delivering goods and services to another location. This is already happening in some sort of isolated lighthouse case studies. I think within the next 2, 3, 4 years, you will see more adoption of these kind of services. Also, autonomous drones becoming more commonplace as a way to deliver over-the-air transport between different locations of goods and services beyond the initial campus areas that we discussed earlier. The third scenario is really about observing and managing large physical spaces. This relates back to the scenario I alluded to earlier that was driven also partly by the pandemic. This is something that, again, we've seen in certain geographies becoming more commonplace, like China and France, for instance. But we already see large oil and gas companies or utility companies using autonomous drones to manage and monitor the grid lines, the power grid lines over longer distance. So again, this is something where we see continuous adoption already evolving and where over the next 2-3 years, we're going to see more and more use cases thriving. The next use case would be about integrating and complementing the existing public transport options with more autonomous vehicles. Again, I alluded to the fact that some of this already exists, but if you look at some of the modern tram and train operators, more and more of these trams and trains are becoming autonomous. And so again, this is something where over the next 2 to 4 years, we're going to see a more widespread adoption. Where we see the longest time horizon is really in the last scenario, the last use case, which is about providing these alternative personal transportation experiences in a private car. And again, I alluded to the issues that we saw in the city of San Francisco, but also other places with robotaxis. And again, because also none of the automotive manufacturer is willing to take the significant risk of somebody getting killed because they're getting rolled over by an autonomous car or vehicle. This is probably going to take a few more years, maybe 5 to 6 years, before we can see full mainstream adoption of fully autonomous vehicles. The other question, of course, that comes with this also is that are passengers, are owners or drivers of cars really willing to give up their personal autonomy as a way to sort of integrate also with other transportation options and be regulated by traffic management systems that give way to certain eco-friendly modes of transportation? That's another question. So there is not only the technology and regulatory barrier or the security barrier, but there's also a level of personal hesitation that has to be overcome in order to make fully autonomous cars really a reality in the near future.
So you mentioned personal hesitation, and that's certainly going to be one of the barriers to adoption with in everywhere, I would think, depending on the kind of how the people feel about it. But there are other barriers to adoption, I would think, like regulatory differences, regional differences, perhaps. Talk a little bit about how you expect that to play out over the next several years, over the set of use cases and the timeline that you just described.
Absolutely. So on the regional side, what we are observing already is that in particular in China, there is not only a strong government push to make autonomous driving a more short-term reality by, for instance, dividing physical spaces into dedicated spaces for autonomous vehicles vis-a-vis spaces that are also for traditional cars reserved. We also see a generation of users in China sort of being more engaged around autonomous technology simply because they like to use it in that way. In Western countries like North America and also Europe, there is more of a personal hesitation. So that regional adoption depends very much not just on the broader regulatory environment, the government push towards bringing autonomous vehicles to the forefront, but also, the way of operating around autonomous technology on the part of the consumer. And, so regional differentiation will exist for some time. Maybe there's one exception in the Western world, which is certainly the city of San Francisco or the state of California, generally speaking, which sort of has become the world's largest test bed for autonomous vehicles. But again, as we saw with the recent events in San Francisco, even there we see some limitations now where people are either getting annoyed by autonomous vehicles blocking the roads, or where in fact emergency services can't get through because robotaxis have broken down and are blocking the public roads. So there is going to be definitely some regional difference. On the regulatory side, obviously the US and also the EU are driving very strict regulatory safety and security policies around anything to do with automation. And so autonomous vehicles are certainly not an exception here. In the US, there's a particular angle to this as well, because there's a strong concern with the government around Chinese autonomous vehicles operating in the American market, because they have to connect to public infrastructure, data infrastructure, and intelligence, and that is raising some concern with legislators around Chinese operators becoming more embedded in a US ecosystem. So that's another element there. And also, as we talked about physical spaces, one has to understand that physical spaces are equally regulated differently. Airspace, for instance, is heavily regulated by the FAA or the equivalent authorities here in Europe. And so that will also put some boundaries around how autonomous drones, for instance, can operate in some of these physical spaces. The human hesitancy we already talked about as it relates to consumers. The other element that we need to talk about is, of course, when we talk about autonomous forklifts or autonomous trucks, how does this basically implicate employee experiences? We've seen some strong opposition from organized labor, for instance, in the US as it relates to autonomous port technology. And so that is something that employers also need to understand, that it has strong ramifications in terms of employee experiences, but also labor law regulations as well. And then maybe finally, and I think also most significantly as it relates to in particular the automotive OEMs, making autonomous technology work really requires to tear down some of the internal silo structures that very strongly exist within traditional OEMs. You have to integrate between the in-car technology, the outside ecosystem of the technology, the traffic management systems. You have to integrate between customer experience and after-sales experience, service experience. And for a lot of these traditional OEMs, this means overcoming internal silo structures. Many of us have followed the struggles of big automotive OEMs such as Volkswagen, for instance, as they try to become more software-centric and have been building up separate organizations to drive some of the software-enabled innovation. But it's really sort of failing in many cases because of how these internal silo structures are preventing the cross-pollination of data and architectures around software, customer experience, in-car experience, after-sales service experience to really make this work end to end. And these are just some of the bigger obstacles that we see.
So I'm realizing that there's an important point that we should probably deal with that you sparked by talking both about the kind of drive in China to go faster towards various kinds of autonomous vehicle operation, and also the kind of struggles that the traditional OEMs have faced in tearing down the silos to build these new vehicle platforms and systems, which is electrification. Because I think in a lot of people's minds, autonomous vehicles are synonymous with electric vehicles, which isn't actually the case necessarily. So I wonder if you could talk a little bit about the relationship between electrification, which of course has positive implications for things like ground pollution in cities, and autonomy, and sort of how people should think about, are all autonomous vehicles electric? Are most of them electric? How exactly do you see this all working?
Well, I mean, the differences are obvious because electric vehicles are all about the drivetrains. Autonomous vehicles are all about the data infrastructure around it. So from an engineering perspective, these are totally different worlds. Again, very different systems, very different people, different types of engineers. That's where the silo structures are currently preventing the integration, the full integration between autonomous vehicle technology and electrification. Again, drivetrain technology traditionally in the engineering world of the automotive OEMs has been a totally different art, a very different kind of element. Also in terms of the ecosystem with suppliers. Autonomous vehicles is all about a data ecosystem. It's all about the integration of data inside car data with traffic management signals, geolocation management systems. That's a totally different story. Electrification is about the integration of different types of suppliers, battery technology, drivetrain technology, steering technology. And again, if you think about it from an engineering perspective, it's quite clear these are two very different worlds. And bringing those together in order to create the cars of the future that enable the mobility of the future is going to be a huge task. And this is a pivotal moment for the automotive industry, because on the one hand, yes, you want to use autonomous vehicle technology as a way to differentiate and also drive better transportation experiences. But because, regulators are pushing automotive OEMs towards electrification more and more, OEMs have to make a choice. Where are they currently placing their bets? And what we are seeing currently in terms of the investment patterns is that electrification currently is the primary concern. Autonomous vehicles, yes, that's certainly something that they are going to work on as well. But it's not that autonomous vehicles would drive significant progress along electrification. They will complement electrification, but they're not the driving force.
Pascal, you had touched on security concerns in a previous response. Can you talk a little bit about the possibility of attacks against autonomous systems?
Well, we don't have to talk about possibilities because it's happening. I mean, it's happening already. We've seen this with a couple of very, sort of prominent cybersecurity incidents. I don't want to name any of the particular OEMs that were involved here, but some very reputable companies have been hit by cybersecurity attacks on connected vehicles where, attackers have made inroads into the autonomous vehicle infrastructure, and not just the autonomous vehicle technology, but actually the in-car technology as well, because these systems are flawed in the sense that they are open to many different architectural dimensions, and that allows for attackers to really take advantage of the different types of systems. So that's something that I think is going to be a key concern. It's also basically why we have not seen OEMs pushing, a great deal of innovation around autonomous vehicle technology beyond level 4 in recent years. And so that it's happening. I think there is another element to this, which is, of course, besides the cybersecurity threat, there's also, the element of insecurity that stems from other parts of the ecosystem sort of providing wrong data. We've seen Tesla's autopilot accidents happening because wrong data was processed by the vehicle, ultimately leading to accidents. And so there are multiple elements here where OEMs are going to be extremely cautious to mitigate the risk, because it's brand risk, but it's also, the physical risk of somebody, suffering injuries or possible death. And that's certainly something that OEMs want to avoid.
To broaden the aperture a little bit, I think a lot of people tend to think first about sort of autonomous passenger and freight transportation options for kind of high cost, high density cities in the rich world. And there are a lot of transportation challenges in the megacities of the developing world that, in theory, should actually be responsive to autonomous vehicles of varying kinds. Because one of the biggest problems you have in giant megacities in sort of middle-income countries is that the people don't live close to where the jobs are, and the transportation options are unreliable, too expensive, dangerous, all of the above. So I'm wondering, looking now at the state of the universe of autonomous transportation options, because I remember this is one of the things I was most excited about back in 2017, even knowing that it was going to be fairly far into the future. Is that a thing that we could see at some point? Because I personally would really like to. So I'm wondering if that's still possible.
Yes, it could be. I think the key driving factor, though, for adoption of autonomous transportation in around large metropolitan cities for public transport stems from another issue, which is skill shortage or staff shortages. You simply cannot find enough tram drivers or train drivers these days. And so I think what we are seeing is one of the reasons why autonomous vehicle technology gets more and more adopted in around public transport is that we simply don't have enough people to do the job manually. And so I think that's much more of a driver than getting people from A to B, in particular in these sort of tier 2 cities where also net income is lower, and for all the social reasons that you outlined, there may be a core driver for this. So one of the more interesting use cases is in the city of Bogota, where a cable tram operator, Doppelmayr, has implemented cable cars that you would usually see in big skiing resorts that have become a major element of the public transportation network. But not because it's running autonomously, but because of the geographical outlet, because it's very hilly, right? You have to go up and down a mountain to basically reach the suburbs of the city. And so cable cars, autonomous cable cars, have become a major, major element to overcome not just the public transport boundaries where people need to move from A to B, but also to manage the geographical boundaries. So there you have very interesting use cases that really drive some of this autonomous vehicles adoption. But again, it's very specific to the geography and to the use case that you find in this space.
So Pascal, you've described sort of the 1 to 3, 2 to 4 year implications of some of the use cases you described, right? But what is your vision for 10 to 15 years out here as it relates to autonomous vehicles?
Well, again, I will start with the commercial and logistics sector, because I think this is where we're going to see not only rapid adoption of autonomous vehicle technology, but even the broadening of the current use cases beyond individual factories and campuses. We already see major investments planned around autonomous trains running end to end across Europe to facilitate freight transportation in not just a more eco-friendly but also more timely manner. Again, this whole need to build better supply chain logistics resilience is going to accelerate, particularly in the B2B sector, the usage of not just autonomous tractors or lorries or trucks, I guess is what you say, but also trains in particular. Also, autonomous drones, we feel, are going to have their place more and more as it relates to not just B2C, but B2B in particular. The other use case I alluded to earlier is everything to do with monitoring large physical spaces. This has become, actually something that also public sector institutions are increasingly aware of as an opportunity to drive public safety. Even in military scenarios, you see autonomous drones observing huge physical environments, and there is a strong need for adoption there as well. So that's becoming clearly also an element where we see more and more adoption. As it relates to personal transportation, again, my sense is that we will have to see the shift towards electrification completed first before we see then significant adoption of autonomous vehicles technology, simply because of how OEMs are having to restructure their whole innovation network to first align with the priority of electrification before they then can tackle the autonomous vehicle technology. I think there's also, from a consumer dimension, a generational shift that is happening. You still have a lot of old people like me who still like to be in control of driving a car, but the younger generation is very different. So we have to allow for these younger consumers to become the mainstream consumers of mobility services, to really push for more autonomous vehicle adoption around a passenger car. And that's why I think the timeline there is going to be a little longer in terms of, adoption across the board.
So, Pascal, we've talked about, a little bit of the timeline, right, of when some of these use cases come to bear and are more common. But what are your thoughts, 10 to 15 years from now? What are we going to be seeing as it relates to autonomous vehicles?
Well, again, I think the use cases that we already see around B2B logistics are only just going to accelerate because of how companies are going to make their supply chains and logistics more resilient and transparent over time. And so I think, the investments that we already talked about in the context of autonomous drones and autonomous trucks are just going to accelerate beyond that. We see already, big investment plans into European train infrastructure, allowing for autonomous trains to run end to end across Europe. So there will be more use cases to allow for speedy adoption of autonomous vehicle technology. One other area where we see massive adoption and really strong innovation is everything to do with public safety and also military use cases. This is, obviously, true in the context of some of the geopolitical conflicts that we are currently exposed to. But it's also becoming clear as an aftermath to the pandemic, where the observation and monitoring of physical spaces is driving significant value in the context of military and public safety use cases. So that's something where over the next 2, 3, 4 years, more investments will happen and where also more innovation will happen to drive the use cases going forward.
Well, thank you so much for joining us today, Pascal.
My pleasure as always.
If you like what you heard today, subscribe to Forrester's What It Means podcast on Apple Podcasts, Google Podcasts, or your favorite podcast player. To continue the conversation, follow Forrester on Twitter, Instagram, and LinkedIn, or drop us a note at podcast@forrester.com. Thanks for listening.